Nikola Tesla.
The Electric Sorcerer, Part 2. At Equitage by Edison's rock crushing factory in Ogden, New Jersey, a local newspaper reporter asked the inventor about the possibility of producing light from electricity without heat. Edison murmured that this feat had been achieved, but the reporter pressed him. He specifically mean with reference to discoveries in the line taken up by Nikola Tesla. Edison rose from his easy chair, spat another wad of tobacco off the porch, and barked. It is a problem surrounded by difficulties. And what about Tesla? He has made no new discovery, the chief wizard began, but has shown considerable ingenuity in increasing vibrations. He gets his results from the induction coil and the Geissler tube. Do you think it will replace your light bulb? Light without heat may be obtained someday, but I do not care to prophesy that it will be a pleasant light. Its biggest trouble is its quality. It is a ghastly color, more like the light of lighting bugs than anything else. Certainly, in this regard, Edison was entirely correct, as even today, the light bulb generates a more pleasant glow than fluorescent tubes. However, as anyone who has changed a light bulb knows, Edison's invention is constructed so as to break down within a few months, whereas Tesla's fluorescent lights can last for years, even decades. Furthermore, according to Tesla's view, the incandescent lamp created a harsh, bright light from a small central source. It was Tesla's plan to create a pleasing light from a very large spherical surface. Now, for the first time, Nikola Tesla was sought after by the popular press, quoted as being modest by many interviewers and sometimes self-effacing. Initially, Tesla avoided publicity, but his sensational accomplishments had made him a folk hero, and it was now up to the journalists to find out why. The New York Herald was the first newspaper to capitalize on the rising star, in a long feature article adorned with an etching drawn from an outdated photograph. The Herald described the inventor's demeanor and his heritage and discussed the full range of his future plans. Mr. Tesla is such a hard worker that he has little time for social pleasures. If indeed he has any taste in that direction. He is Abishala, tall, very spare build, has dark, deep-set eyes, jet-black hair, and an expression that suggests at once the deep thinker, though polite and even friendly to newspapermen. He has no desire to exploit himself in print. Tesla described his parents and schooling, his invention of the rotating magnetic field, and also his new system of lighting, which he promised would be a more practical illuminant than we have at present. He discussed the possibility of sending vast amounts of electricity along wires from Niagara Falls, and also the concept of wireless transmission of intelligence and power through the earth and air to any distance. From present experimental evidence, it can be quite safely concluded that an attempt to transmit intelligible sounds through the earth from here, for instance, to the European continent without any cable will succeed beyond a doubt. Such a result, which I have advocated for 2 years if achieved, would, of course, be of incalculable value to the world and greatly advance the progress of the human race. The Herald ended with a question about how it felt to send hundreds of thousands of volts through the body, and Tesla replied, "If you are prepared for the shock, the effect on the nerves is not nearly as great. Initially, you feel a burn, but beyond that the feeling is scarcely noticeable. I have received currents as high as 300,000 volts, an amount which, if received in any other way, would instantly kill." Although the travel and the lectures were digressions, Tesla accepted the engagements to solidify his place in the history of electrical science. For the cloistered conceptualist, naturally, the accolades and interaction with colleagues were also inducements. However, it was only now, as he was being sought after by reporters and the adoring public, that he began to realize, in a conscious sense, his latent desire for recognition. Every hour, every moment that was not spent working on inventions was time away from his purpose. Even the intervals spent eating and sleeping delayed progress. Although both his parents had passed away at relatively young ages, there were other kin whose lifespan had traversed more than 10 decades. Perhaps in part as a defense, Tesla would exclaim that he expected to attain centenarian status. He had come to see the human body in its essence as a machine, one that could be efficiently regulated by the stern application of willpower. And so Tesla exerted his will to reduce his sleeping to a minimum and his eating to the bare necessities. Although over 6 feet tall, he kept his weight to a scant and unvarying 142 pounds. The strain was beginning to show, but the Serb was on a quest. His goal was nothing short of saving the whole of humanity through the application of his fertile brain. having transmitted energy by means of wireless from one end of a room to another. The inventor's next task was to devise a way to extend this principle to generate larger amounts of power and to create separate, non-interfering channels. Tesla began to experiment with more and more powerful oscillators, ones that would not only radiate high-frequency AC, but also ones capable of engendering physical pulsations. The first gratifying result was obtained in the spring, when I reached tensions of about 1 million volts with my conical coil. That was not much in the light of the present art. Tesla wrote a quarter of a century later, but it was then considered a feat. According to calculations performed by Professor John Tyndall, the Edison electric light bulb had an efficiency of about 5%, meaning that 95% of the electricity produced went into the production of heat or was simply lost in transit. The gas flame, which was still by far the most common form of artificial luminescence, had an efficiency of less than 1%. As Tesla told Martin, if we were dealing with a corrupt government, such wretched waste would not be tolerated. This squander was on a par with the wanton destruction of whole forests for the sake of a few sticks of lumber. The energy, as Martin wrote, is more or less frittered away, just as injally the load in an iceman's cart crumbles and melts along the street. Whereas armies of inventors have flung themselves on the difficulties involved in these barbaric losses occurring at every stage, Tesla had designed an entirely original series of inventions which either converted electricity to rotary action or practically the reverse. That is, converted steam power into electrical energy. In the first instance, Tesla constructed a high-frequency oscillator which was immersed in avat of oil. By modulating the frequency of an AC, he caused the oil to flow at varying rates. Just like a water wheel turning a turbine, this oil caused a blade to rotate. By increasing the frequency, the flow would change, and the rotation of the turbine would be increased. In the second instance, that is, in the case of the steam generator, Tesla combined into one invention both an engine and a dynamo, and created a device that was as much as 1/40 the size of comparable traditional constructions. In the old-fashioned steam engine, the reciprocating back and forth piston action had to be converted to rotary effect by way of a crankshaft and flywheel. This device, in turn, was connected to a turbine, which thereby produced electricity. In the Tesla generator, a steam-driven piston attached to a condenser was made to bob up and down within a magnetic field, cutting the lines of force, thereby producing a current. This procedure reduced markedly the loss involved in converting mechanical action to electrical power. There was no flywheel or crankshaft. Martin eloquently wrote, "We note immediately the absence of all the governing appliances of the ordinary engine. They are non-existent. The steam chest is the engine, bare to the skin like a prize fighter with every ounce counting." Denuded in this way of superfluous weight, and driven at high pressure, the engine must have an economy far beyond the common. With an absence of friction due to the automatic cushioning of the light working parts, it is also practically indestructible. Furthermore, whereas the ordinary steam piston, weighing perhaps as much as 1,000 pounds, could only change its direction, say, 10 times per second, the Tesla oscillator could oscillate at 100 strokes a second. Tesla hoped not only to reduce the complexity of existing equipment, but also to create a current that would maintain a vibration with perfect constancy. He took out patents on both of these devices in the summer. With these various oscillators, Tesla could provide a plethora of effects. Electrically, he could generate precise frequencies that could be used to transmit information or electrical energy. When the oscillator was pulsating at the frequency of light, he could manifest luminescence as well. And mechanically, he could create pulsations through metal bars or pipes and test for harmonic frequencies and standing waves. By studying impedance phenomena, he could transmit electromagnetic energy through such a conduit and cause a light to illuminate at certain positions along its length but not at others. And if he increased the vibrations and struck a harmonic frequency, he could get the iron rod to begin to vibrate with such intensity that it would crack itself in two. This effect was equivalent to that produced by Joshua's horns at Jericho, or to the danger that could be initiated by soldiers marching in lockstep across a suspension bridge. If their beat struck the resonant frequency, the bridge could sway violently and possibly collapse. Thus, soldiers are trained to break stride while walking across bridges to avoid this amazing type of catastrophe. End of Nikola Tesla, the Electric Sorcerer. Part 2. Thank you for watching.